The views and opinions expressed in this program are those of the speakers and do not necessarily reflect the views or positions of any entities that they represent. This program is intended for educational purposes. You're listening to
आप सुन रहे हैं
You're listening to
നിങ്ങൾ കേൾക്കുന്നത്
ನೀವು ಕೇಳ್ತಾ ಇದ್ದೀರಾ
Radio Azim Premji
ಯೂನಿವರ್ಸಿಟಿ
Hello and welcome to What About Science on Radio Azim Premji University. I'm Nandita Jayaraj, and this is a podcast where we try to make sense of the science making news in today's world, and also the science that's set to make news in the future. Just about 30 kilometers from the university in Hoskote in Karnataka is a building full of cutting-edge, high-precision machines. The purpose of these machines? To polish and prepare 86-odd hexagon-shaped mirrors and ultimately ship them off to Hawaii, the proposed site for one of the world's largest telescopes, the 30-meter telescope, or TMT. At least that's the plan. The TMT could tell us about supermassive black holes, the early universe, planets outside our solar system, and the possibility of life in them. But that's not all. The TMT story is also about cross-country collaboration and the rights of indigenous communities over their land. On this episode of What About Science, we're going to properly sink our teeth into the many facets of the TMT story. And helping us out is our guest for the day, Proteep Mallik. Proteep teaches physics at Azim Premji University. He worked as an optical engineer and in instrumentation for many years and is passionate about astronomy. I don't think I need to convince anyone any further that Proteep is the person for today's job. Welcome to the show, Proteep.
Thanks, Nandita. Thanks for having me.
I've always known Proteep as the astro guy at APU. And there's a good reason for this. His tryst with astronomy started way back. As a child of astronomers, dinner-time conversations for him were usually about a new scientific discovery or a new image from the Hubble Space Telescope. It shouldn't be so surprising that the astro bug bit him as well, and he chose to study physics. Pradeep's expertise is in a field called optics, the study of light. Optics is crucial to astronomers because unless we know about the behavior of light and how to manipulate it, we wouldn't be able to detect light from the distant universe. And that's what telescopes do, right? Over the years, Proteep worked in the area of telescopes and telescope building, and that's the background he brought with him to the university.
Once I started teaching at Azim Premji University, I felt that, students actually come in with a lot of passion and a lot of interest in astronomy. So how do we engage with these students outside of the classroom to continue, to make sure that this passion continues to burn in them so that maybe someday they go out there and do something great in astronomy. So these are some of the ideas with which we came up with things like the physics club, the astronomy club. The university, essentially funded the purchase of a nice 8-inch telescope that we have on campus. That's how I think over the last 6-7 years we've kind of built up some kind of regular culture of astronomy events and various things happening on campus. And astro guy, I don't know if I would consider myself, somebody who's the astro guy. It's the effort of a lot of people.
The telescope here at the university, or even at any planetarium for that matter, can generate really cool images of space. But believe it or not, these are incomparable to some of the large telescopes that we have on our planet today. The upcoming 30-meter telescope is said to be one of the largest ground telescopes on Earth and the largest in the northern hemisphere. Let's take a minute to compare this with the telescopes of the past. Galileo's first telescope was just 20 to 30 millimeters. From then on, people realized that the bigger the lens in the telescope, the more the light that can be collected, and the further in space that we can see. But there's only so big a lens can get, because otherwise we will have an impossibly heavy telescope that we can't maneuver. Then we started using mirrors. But how large can a mirror get?
So it required technologies in the 70s and 80s, 1970s, 1980s, where people started developing novel ways of building very large mirrors but make them very light. So how do you do that? So again, you look towards other things in nature. So the beehive is a lovely example where you have these hexagonal honeycomb structures. The beehive is very sturdy and stable, but there are all these hexagonal holes in them, and the hexagonal ribs of these holes actually keep the structural stability of that beehive. So why not try and do something like that with large mirrors? And so a pioneer of this was actually this person called Roger Angel at the University of Arizona. The personal connection there is that I had a chance to work with him during my graduate days. And he essentially figured out a way to build 8.4 meter diameter mirrors that are, hardly maybe a little over half a meter thick, but they have these hexagonal support structures built into the mirror that kind of keep the mirror very stable. So when we say large today, we're the largest telescopes that currently run and work and have been collecting data are about 8 to 10 meters in diameter. We don't have anything larger than that currently. So the next generation of large telescopes would be telescopes that are in the range of 25, 30 meters in diameter, TMT being one of them. The other one that's coming online is called GMT, Giant Magellan Telescope. My connection to that is probably a little closer because that telescope is being built out of mirrors that are made at the University of Arizona. And in fact, I was still a grad student there when they cast the first mirror, and I used to actually give these mirror lab tours as a tour guide.
These are massive telescopes. Projects like the TMT and GMT obviously involve a lot of planning, engineering, and of course a lot of money. What kind of astronomical secrets are we talking about here that makes all this effort and resources really worth it?
I would say there are two major pushes for having these very large telescopes. One is to look into the very distant universe and see if we can get close to the time of the origin of the universe and see what the universe looked like then. There are a lot of theories, obviously. So do we actually see some of those theories? Were there galaxies then? Were there stars then? Was there something else? How did galaxies form? How did stars form? These are the kinds of great questions that people have about the early universe. And also about the current universe, the questions are things like, is there life on other planets other than in our own solar system? What are the other kinds of things, that one can learn from those, observing planets around other stars. So I think the main push for building these larger telescopes comes from that. The exact difference between GMT and TMT in terms of their science goals, I think they're very similar. Why are we building two 30-meter telescopes? One is that there are a lot of astronomers. They need to stay employed. They need time on telescopes to collect their data. And telescope time is in very short supply. There are not that many very large telescopes. So the more of these large telescopes you have, the more data you can collect. There is absolutely no dearth of discoveries to be made.
Okay, Google, how far from Bangalore to Hawaii?
13,137 kilometers.
That's a far way off. So why are scientists sitting here in India so excited about a telescope coming up on the other side of the world? You see, India is one of the multinational partners involved in making the TMT happen.
So the 30-meter telescope is essentially a consortium of international partners and countries. So you have Japan, Canada, China, and then India signed on in 2014 as a partner to TMT. What partner actually means is that obviously the TMT started contacting people to see if they're interested in signing up as a partner, which means that you have to give some money. And in return, what you get is that scientists in India will actually get telescope time. They'll actually be able to use this telescope. And like we mentioned earlier, it's very hard to get telescope time. There are thousands and thousands of astronomers that will send proposals and fight over, 200 nights a year of telescope time that's available. And, most astronomers come away disappointed because they don't get time on the telescope. So India is a 10% partner on the TMT, which means effectively they get something like 36 nights a year, which is actually a huge amount. 36 nights a year is quite a lot of observing time, and Indian scientists will be delighted by that. That's not the only thing India gains by giving $200 million towards this $2 billion project. It allows India to actually develop technologies. So one of the things that India is doing is that they're going to build these 82 or 86 segments, mirror segments. So they will learn the technology of how to grind and polish and then measure, and then also figure out ways to integrate these hexagonal segments into this larger mirror, right? So each of these tiny hexagonal segments has to be tiled with other hexagonal segments to make the telescope mirror act as if it's one single piece of glass. It's very, very hard to do. So the Indian scientists and engineers and private industry in India will learn how to actually build this very, very complex structure of mirrors. The other thing that India is also going to do is to provide a lot of software and control systems for the telescope.
The site of much of this action is just 30 kilometers from the APU campus. Proteep has actually been to this facility. It's called Center for Research and Education in Science and Technology, or CREST. In fact, he took his students there.
They have a very, very large clean room facility that's been built, a really state-of-the-art kind of facility. And I was teaching a course, interestingly, not the astronomy course, but a course called Understanding India, Science and Technology, and the Future of Science and Technology in India. So I wanted my students, who were actually mostly from non-science backgrounds, to grapple with the ideas of what does it mean for India to spend $200 million of taxpayer money on this extremely large and complex and somewhat esoteric project as far as the general public is concerned. And I think most people in India would not have heard about the 30-meter telescope.
Pradeep and his students got to see for themselves the mirror segments, the polishing machines. And some of these cutting-edge, super expensive machines will stay back in India even after the TMT construction wraps up. That's really a big part of why India is making such a big investment.
We will hopefully be able to use these machines to make our own, let's say, 8 or 10 meter class telescope. So that's the idea. Now, where will that telescope go? It will have to go on Indian soil. And one of the great places now for astronomy that I'm sure many Indians are beginning to hear about is in the Himalayas, actually the Trans-Himalayan region of Ladakh, a little bit beyond Leh, about 250, 300 kilometers from Leh. There's a town or village called Hanle. And there is the Indian Astronomical Observatory, which is run by the same facility that's building the mirrors for the 30-meter telescope. The institution is called the Indian Institute of Astrophysics. So we will have these machines, and hopefully, after the TMT segments are sent off, we will put these machines to use to build our own, maybe 10-meter class telescope that'll probably come up somewhere in near Hanle, and there Indian scientists will have all 365 days of the year to use that telescope and make the kinds of discoveries that other current large 8 or 10 meter telescopes are making.
Would you say that your understanding India students were convinced by what they saw, or were there any interesting questions that came up?
So I don't think anyone, even myself included, would be fully convinced of any one of these projects. But ultimately, I think the way many of us scientists justify these projects, and maybe even some of the students, is that for the greater good of scientific discovery and this indomitable spirit that humans have, that we should set our visions, very far ahead and continue to power along and build these very, very large, exciting, complex kinds of instruments. Because there are, the other justification is that there are a lot of other interesting things that can come off it, unintended consequences, maybe even. NASA, the US Space Administration, keeps talking about a lot of these technologies that were developed for the space shuttle or space missions are currently used by us today. Materials that we use, things like Velcro, various kinds of clothes that we wear, various kinds of heat-resistant kinds of materials, insulation, even people will say even things like detectors. So I think there are good reasons to be involved with a project like this. And I think many students were at least impressed that, right here in our backyard, we're doing something as complex as the 30-meter telescope, fully involved with, scientists, engineers, a lot of private kind of partners building their capabilities, which will lead to other things. A lot of those capabilities will go into building, many other things besides the telescope eventually.
The TMT has been described in media reports as the most controversial telescope on Earth. And in another place, it was described as a 30-meter elephant in the room. Most of these have to do with the long-standing protests that have been happening by the indigenous Hawaiian people against the construction of yet another telescope on the Mauna Kea mountains, which they consider sacred to them.
Those against the building of the 30-meter telescope atop Mauna Kea are expressing their opposition, loud and clear. On Maui, people held signs and waved flags in front of UH Maui College and the Queen Ka'ahumanu Center. Over on Oahu, a demonstration took place on the H1 freeway in what's called a slow crawl. Cars, trucks, even mopeds nearly stopping traffic.
Protesters on the mountain call themselves the Kiai, or protectors. They say their current struggle is yet another chapter in a long history of racial discrimination.
Pradeep may be a telescope-crazy scientist, but he's no stranger to the social repercussions of big science projects.
My mother was an observational astronomer, and she would make monthly trips to Kavalur, near Vellore, at the Indian Institute of Astrophysics, the Venu Bapu Observatory, and use their 40-inch, 1-meter telescope to study things that she was interested in, stars and metallicity in stars and so on. And I used to, as a young kid, obviously I don't remember my first few visits because I was a few months old, but every year I would probably make half a dozen trips to Kavalur in this very, very beautiful part of the forests, what are called the Javadu Hills, outside of Vanyambadi. And really, really lovely place, dense forest, dense jungle with a lot of wildlife. We would see wild elephants, we would see deer, enormous diversity of birds, lovely trees, and so on. In the midst of that, you have this 100 or 120 acre campus. So a lot of the people who worked at the observatory came from neighboring villages. And I remember even as a kid kind of thinking about the fact that here there is this group of scientists from the city of Bengaluru, many trained in different parts of the world, coming to a very, very tiny, small village of Kavalur and essentially taking over 100 acres of forest to do their science and have local communities kind of support that. So we always, so this idea that you need the support of a local community to do this kind of work in a place where you want to do it was something that I had thought about long time back. And this issue is playing out in the TMT. So the Hawaiian people, I think, have completely valid, legitimate reasons to feel that their sacred kind of lands on Mauna Kea are being completely overrun by essentially these massive buildings and domes that are doing very esoteric things that may have no connection to these communities. And the 30-meter telescope is especially large, is especially in a region of Mauna Kea where they have to build it, they have to level a lot of land to build it.
The protests in Hawaii were so intense that at one point TMT backed down, and they even decided on a backup location on the Canary Islands. But as of now, it looks like they're sticking with Mauna Kea. The whole issue was litigated, and while there is some question about whether the litigation went off in a fair way, they ultimately ruled in favor of TMT, saying that the telescope can go ahead and build, with a few caveats.
It's a very complicated debate. Even for me to think about, Kavalur as a young kid, seeing what happens there, what happened there, and then later on in my 20s, seeing what was happening in Arizona and on Kitt Peak, and now seeing what's unfolding on Hawaii is difficult to process. So you look at any picture of the mountain, even from a distance, the top of the mountain is not smooth like most mountains are. You see these buildings and domes and structures on there. So I can imagine as a native person looking at that mountain and seeing that it's completely scarred by science.
It feels a bit much, doesn't it? Despite all these hurt sentiments and damage to communities and ecologies, astronomers are still hung up on building on this particular mountain. What is it about the Mauna Kea?
The thing, though, is that there are very few sites on the planet that are good for astronomy. Hawaii and Mauna Kea especially is particularly excellent for astronomy. The peak is close to 14,000 feet high, which is actually very close to the Hanley telescope height. But it has even more advantages, which is that it's relatively accessible. It's surrounded by the Pacific Ocean, which is this lovely thermal sink. So the temperature over the Pacific Ocean, it creates some kind of an equilibrium. You have this very nice laminar flow of air and wind over the mountain. So you don't have a lot of atmospheric turbulence and a lot of these turbulent effects which cause blurriness of images of stars and galaxies. Again, because it's so high up, you have less amount of water vapor, it's drier. It's a very stable, really probably one of the best sites on the planet to do astronomy. Almost, almost like space astronomy. I mean, you're far away from the soupiness of the atmosphere that you can even imagine doing infrared astronomy, other kinds of astronomy that you couldn't possibly do at lower elevations. So, I think, so that's the
two sides.
The two sides.
When the plans for TMT first began, the idea was for it to start functioning in 2022. That was supposed to be when the telescope achieved first light. First light is the technical and rather poetic term for the moment when the first starlight falls on the detectors of the telescope.
If you go to the website and look at the timeline right now, it says 2027 as the date for first light, which is only 5 years away. Given how complex the whole instrument is, and given so many people involved, we've just come out of 2 years of a pandemic and so on, I doubt the 2027 deadline would be met. I mean, I don't want to be a pessimist, but my guess is that maybe somewhere in the 2030 kind of time frame over the next 8 or 10 years, one should expect first light from that telescope.
Final question. It's a hypothetical one. So, say that instead of Aladdin's magic lamp, you find a magic telescope that you could rub and envision anything at all in the universe. What would it be for you?
It's a great question. earlier I mentioned maybe a couple things that would be really interesting for a telescope to be able to see and discover. One of them is actually essentially impossible by the laws of physics. So I don't know if Aladdin's magical telescope could overcome the limitations of the laws of physics. It can.
Yeah.
Okay. So it's a very generous kind of Aladdin. I mean, in that case, I really think that if the telescope could look at the event of the Big Bang, I mean, that would be just mind-shattering. But again, as a physicist, I know that that's absolutely impossible. There was a period of time, the first few minutes of the Big Bang, where the matter was so dense that even light couldn't come out of it. So if light or electromagnetic radiation cannot emerge, how are we going to get that signal, right? That's the signal that we're getting.
If that ever came true, it probably means there's something wrong with the Big Bang.
Exactly. So if Aladdin could overcome the laws of physics to say that, yes, you can actually see the event of the Big Bang. And the event of the Big Bang, the thing is, the point is called a singularity. The other thing I think would be to be able to image other beings on some other exoplanet. Maybe I'm too much of an idealist or too naive to believe that this is true, but I think that if we actually discovered life on some other planet, I would imagine that most people would really pause to think about what we are doing to our own planet in a more serious way. I envision that if we actually found life somewhere else and we learned something about it, maybe we would stop having conflicts on the Earth. Maybe we would be better stewards of the environment. But anyway, this magical telescope, through that you could possibly learn about how is that society, if it's an advanced enough, intelligent society, how are they dealing with their issues of traffic, environment, human conflict, inequality, stuff like that. So this magical telescope could detect all of those in some other society, and we could, obviously use it to good rather than evil, I'm hoping, and be able to learn a lot so that we ourselves become better people.
This was a really interesting conversation, Prateep. I know some of these questions were probably a little mundane for you and others were super complicated, but you answered both with really equal care and interest. So thank you so much for being on the show.
Thank you. This was fun.
And that's all we have for you this time. If you want to know more about what we talked about in this episode of What About Science, make sure you don't miss the show notes, where we share links, resources, and acknowledgements just for you.
You're listening to
आप सुन रहे हैं
You're listening to
നിങ്ങൾ കേൾക്കുന്നത്
ನೀವು ಕೇಳ್ತಾ ಇದ್ದೀರಾ
Radio
Radio Azim Premji
ಯೂನಿವರ್ಸಿಟಿ